Okay, guys, what we're going to do today is we're going to take kind of a step backwards and work on solving equations with exponentials and logarithms. When you solve an equation, you are basically using inverses to undo what is there. So when you add, you need to subtract. When you divide, you need to multiply. Well, the same thing is going to happen when we use exponentials and logarithms. Remember that exponentials and logarithms are inverses. Okay, so if I have a 10 raised to the x and I take the log base 10 of it, like that, it's going to equal the x. And that's what I want to happen in an equation. If I have e to the x in an equation, I take the ln of that and it gives me x. Okay, if I have a logarithm in an equation like this, I take that equation and use it as a power, put a 2 under it, and get that. Okay, so I'm going to use this property of inverses to help me out. Okay, all right, so we're going to start with a fairly simple one. Okay, let's start with an exponential. So we're going to go 3 raised to the x is equal to 400. Now you will need a calculator for this. Okay, you either get to use a calculator or you get to use some really old table that they used like a long time ago. All right, so what we're going to do is we can actually use any logarithm we want to solve this. So I'm going to use log base 10. Okay, so I'm going to take the log base 10 of both sides. Okay, now what's going to happen is this guy will come down like that. You could also use log base 3. Okay, but depending on the calculator that you have, it might just have log base 10. So you want to be careful with that. Okay, so I'm going to divide both sides because it's turned into multiplication. And there's my answer. Now, if I want a decimal approximation, okay, I'm going to get out my calculator. I'm going to use the log button. And I get 5.45. All right, let's find another problem to do. All right, so let's do something a little bit tougher. Okay, again, it's going to be an exponential, but it's going to be a little bit tougher. So this one, all right, now notice this has an e. So typically when people see e, they use what's called the natural log or ln. That should also be a button on your calculator. Okay, so what we're going to do is we're going to add the 8 because we want to get the exponential isolated. So we get 39, okay? And then we're going to take the natural log of both sides. Now, since it's ln and e next to each other, what's going to happen is those are going to cancel out right away because those are the bases match and they're definitely inverses. So x is equal to the natural log of 39. Let's type that into our calculator and see what happens. 3.664. Okay, now most calculators, okay, have base 10 for log, okay, the log, and then they have a natural log button. If you have a graphing calculator like a TI-84CE button, they will have what they call a change of base button, okay, built in, and you can totally use that. That's perfectly fine. Okay, let's move along. Do something a little bit tougher. Okay, let's try this one. Okay, so this one has a natural log. So we're going to use base e to help us out. All right, so this says the natural log of 3x minus 1 is equal to 5. So what we're going to do is we're going to use our equation as an exponent. So we're going to put an e underneath everything like that. Okay, what's going to happen is these two guys will cancel out, and I'm left with this. So e raised to the fifth. Now e raised to the fifth is just a number. Remember, e is not a variable, it's a number. It's 2.78 and change. So what we're going to do is we're going to add 1. Divide by 3. Okay, this is what they call an exact answer. Okay. All right, so if I want a decimal approximation, I would type it into a calculator. So let's see. E raised to the fifth plus 1. Okay, so the top number is 403.429 divided by 3. Or you can just let your calculator hold that for you. And I get 134.476 approximately. Okay. All right. So let's try another one. Okay, now let's try this one. All right, so what we want to do, ladies and gentlemen, is we want to get a single log on both sides. If you remember from previous lectures that subtraction of two logarithms is actually division. So I'm going to rewrite the left-hand side as a divide problem, like that. And then I'm going to use the e, just like that, so that'll cancel. Okay, remember that e squared is just a number. So what I'm going to do is I'm going to solve this by cross multiplying. Okay, so x times 1 is just x. Then e squared times x plus 1 like that. Okay, now this is going to look really strange, okay, but it's all right. Okay, remember, e squared is just a number. Let's write that down. It's nothing scary. All right, so now what I'm going to do, believe it or not, is I'm going to distribute the e. Okay, now I want to get all my x's together. So I'm going to subtract. Again, this looks really bad. Okay, so on the left-hand side, I have x minus e squared times x equals e squared. Okay, so now, okay, I have a common factor of x, so I can factor that out. So x divided by x is 1. Then e squared equals e squared. Okay, got to move this up a little bit. Now, I'm actually one step away from being done. Divide off the 1 minus e squared so I get x is equal to e squared divided by 1 minus e squared. Okay, that's an exact answer. If I want an approximate answer, then I'm going to use my calculator. Okay, I get negative 1.1565. Okay. All right. So that is all. Okay. So we're going to do some more. So I will help you out in a moment.